Hello everyone, today in this video we'll be discussing the last module of 18MATDIP41, which is regarding probability. Okay, so this PDF can be found in the link given in the description box, and there are just two topics here. Okay, the first one is the base theorem and the second one is the remaining topics. Okay, so if both of them are interconnected, so it is like just one topic. Okay, so let's have a look at the previous year questions what were asked, the questions which are in the model question paper. So if you observe carefully, what they have asked is to state the axiomatic definition of probability. So here you have to know the definition as well and prove that A union B is equal to A plus B minus A intersection B. And here is one type of question. Another type of question is here we have to use Bayes theorem or the conditional probability. State and prove the Bayes theorem. Both you need to know. And here is the question, and here's another question. Okay. So which type of question for how you have to do that, I'll be explaining you in this video, and I'll be teaching you some shortcuts which can help you score more marks in less time. Fine, so let's get started. And before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. Okay, so let's get started. Move on to the notes part. So in the notes part, the basic terminologies of the probability are given. What is the random experiment? Whatever trails we do, that is called as random experiment. Trails means simply throwing the die. Each of those die is a random experiment. Okay. And what is a sample space? Sample space means all possible outcomes, that whole group. All possible outcomes, that whole group is called a sample space. And what is a sample? Something from that is known as a sample, and event is nothing but a subset of the sample space. This is the possibility of all the events, and here is the small subset of it. This is known as the event. Okay, this is the sample space, and this is the event. Mutual exhaustive event means what? All the events, if we take it as a union, it will be forming the whole sample space itself. Okay, mutually exclusive is what? Two or more events are said to be mutually exclusive. The happening of one event prevent the simultaneous happening of the another. Like all are not interconnected. Like A of I is a of I intersection A of j is equal to 5, means nothing is common in between them. That is known as mutually exclusive. And independent event means it does not affect each other. This event happening does not affect this event happening. Okay, so these are the basic terminologies. And moving on to the axiom of probability, there are two axioms of probability. If S is the sample space, all the events happening is in S, and A be any event in S, means many events are there. Take any event and call it as A, and then what we are doing is the real valued function P of A is known as probability of event A. P of A is what? Probability of event A happening. Probability of S means all the sample, whatever the events are there, happening of all of that is obviously 1, because all these events are included. The sum of all of this is equal to 1 itself, right? For every event A, the probability lies between 0 and 1, and that's the first part. Second part is if A1, A2, A3 are mutually exclusive event, then P of A1 union A2 union A3 is equal to P of A1 plus P of A2 plus P of A3 till P of A, and this is known as axioms of probability. So make sure you know it very well, because this was asked in the previous model question paper. Okay, addition rule is that P of A union B is equal to P of A plus P of B minus P of A union B. Okay, so here the proof is given. It's very simple, you can go through it. Here the figure you have to draw. In this figure you have to draw two circles. First circle is A, second circle is B, and inside that there are three regions. This is A intersection B intersection B intersection B, and you have to write in the same way here. Okay, actually it's not A intersection B. Here it is. If you observe carefully, it is A intersection B bar, A intersection B, A bar intersection B. Okay, so in the same way it is written here as well. Like whatever the equation they have written here, that you have to memorize. And they are taking union, so union means this union, this will happen. So they have written the same thing here. And P of A, just add P in the starting part of each of this, and then add both of them. When you add both of them, this will be the equation, and when you simplify, it will become this. Okay, so that's what the proof of addition of probability is. This is one of the another question from the exam point of view. Okay, important one. Then conditional probability. Conditional probability, observe carefully what it is. P of probability of B happening given that A has happened. Probability of B happening given that A has happened is equal to probability of A and B both happening divided by probability of A. Okay, this is the conditional probability, and the second variation is written here. Just instead of B by A, it is written A by B. Okay, multiplication rule. P of A intersection B is equal to P of A into P of B by A. Okay, if there are two independent events, then P of B by A is equal to P of B. Okay, so this will be equal to what? P of B. So it will be P of A into P of B, right? P of A into P of B if it is independent event. So P of A intersection B is nothing but P of A into P of B. Okay, so that was about the conditional probability and the multiplication rule. Coming to the Bayes theorem, you have to remember it in this way. AI is the an event which is a part of the sample, and A is a event which has already happened. Probability of A of I happening given that A happened, that is equal to probability of A of I into probability of A by A of I. Then the summation of all, like we are taking one out of all of the summations, right? So that is the probability of that particular event. If we and the proof is also given here. This is also very important. They have directly asked the proof as well in the model question paper, so I'll help you in understanding this. See, S is equal to A1 union A2 union A3 till AN. Okay, this all combined it will form S, right? And A is equal to S or intersection A. What is common in S and A? Obviously A only, right? That is equal to this whole, instead of S I am writing this, then intersection A. Now if you use distributive law, A1 intersection A union A2 intersection A union A3 intersection A till union AN intersection A. That's what it is written here. Now for since AI intersection A for I is equal to 1 to n are mutually exclusive, by applying the addition rule of probability, what we can write is P of A. Just add P here. P of A is equal to P of A1 intersection A, P of P2 intersection A, and so on. Now applying the multiplication rule onto each term in the RHS, we have just multiply B of A1. Like what is the expansion of this one? This I already told you, the multiplication rule. The expansion of this one is this one, right? In the same way we are writing here as well. So when we write in the same way and expand, what we'll get is the summation of this P of AI into P of A by AI. Okay, now P of A I by A, that is equal to, it is written in this form, and this form is written in this form. Okay, and P of A remains same. So therefore in the denominator of RHS we have the whole summation of P of A, that is written as P of AI into P of A by AI for all the terms I is equal to 1 till n. Okay, that's what you have to write and practice 3 times, then only you will get to know in your brain. Fine. So that's that way the basic concepts. Let's move on to the problems. In the problems I'll be discussing few problems and how to solve. Like all the problems are mixed here. Okay, observe carefully and read carefully what's happening. Okay, from the 5 positive, how many positive numbers are there? 5 positive numbers are there. Okay, and 7 negative numbers. How many negative numbers are there? 7 negative numbers are there. 5 numbers are chosen at random, means it can be either from this one or from this one or from both. Okay, that is not specified from which one it is chosen. It is just chosen at random and multiplied. What is the probability that the product is a negative number? What is the probability that the product is positive number? Now tell me, when will be a product a negative number? When there are odd number of negative numbers. When there are odd number of negative numbers, then only the product will be negative, right? If there are even number, it will cancel out and it will be positive number. So in negative number, when it will happen, when the negative numbers are odd, the product will be odd when negative numbers are odd. Okay, so that's what we are written here. Sample space contains how many? Means how many total possibilities are there to pick? We are picking 5 random numbers. From how many? 5 positive and 7 negative. That means totally 12 numbers are there. From 12 numbers, how many we are picking? Just 5. So how many combinations are possible? 12C5, which is 792. 792 products are possible. Okay, by selecting 5 numbers from 12 numbers. Now the number of negative numbers can be 1, 3 or 5. Since you are picking 5, either 1 can be negative, 3 can be negative, or 5 can be negative. Then only the product will be negative, right? So if 1 is negative, the rest 4 will be positive. If 3 is negative, the rest 2 will be positive. If 5 is negative, 0 will be positive. For each of these, the different combinations are written here. For example, if 1 is negative, how many negative numbers were there totally? 7 negative numbers. Choosing one negative number out of 7 negative numbers is 7C1 into choosing 4 positive numbers from 5 positive numbers, that is 5C4. The total probability will be multiplied, that is equal to 35. The same goes for the next one, 3 negative and 2 positive, as well as 5 negative and 0 positive. Whatever answer we get, we are supposed to add, because it can be either this one or this one or this one. Wherever there is or, you have to add. Wherever there is and, you have to multiply. Listen carefully. Wherever there is odd, you have or, you have to add. Okay, wherever there is and, you have to multiply. So you will be adding these probabilities here, and the total number of probabilities we calculated is 792, right? Total possibilities. So 406 by 792 will give us 0.5126. That's your final answer. Okay, and the next one is positive numbers, positive product. Obviously from all the product we got to know the negative products. Just subtract 1 minus the negative ones, you'll get the positive ones. Very simple. 1 minus the negative ones, you'll give the positive one. Fine. Moving on to the next question, two fair dice are rolled if the sum of the numbers obtained is 4. See, two fair dice are rolled, sum of the obtained number is 4. How many possibilities are there? 1, 3, 2, 2, 3, 1. Find the probability that number obtained on the both dice are even. Only this probability is there. How many total probabilities are there? Okay, how many total probabilities are there? There are totally how many cases? 3 cases are there. When a number is obtained as 4, 3 cases are there. 1, 3, 2, 2, 3, 1. Among those, only this one has even numbers on both the dices. So therefore the probability is 1 by 3. Moving on, what is the probability that a leap year selected at random will contain 53 Sundays? Leap year means how many days? 366 days. 366 days is nothing but 52 weeks plus 2 days. Okay, 52 weeks plus 2 days. 52 weeks will have how many Sundays? It will have 52 Sundays. Now we are just concerned about 53rd Sunday. The 2 extra days can be what all? What all the 2 extra days can be? Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, and so on. So in these possibilities, there are totally 7 possibilities, right? 1, 2, 3, 4, 5, 6, 7. In these 7 possibilities, there is a Sunday coming here and a Sunday coming here. So 2 by 7 possibilities, you can get a 53rd Sunday. Because 52 Sunday and 52 Monday, 52 Tuesday, everyone will get. That is not the point of consideration. 53rd Sunday will be happening when there is 2 possibilities out of 7 possibilities. If it is a normal year, only 1 extra day will be there. So Sunday, Monday, Tuesday, Wednesday, Thursday will be there. Thursday, Friday, Saturday will be there. Out of 7, only one of the chances there that Sunday will come. So 1 by 7 will be the probability in a normal year. 2 by 7 will be the probability in the leap year. Okay. Moving on, we have the next question, which is an urn contains 5 red and 10 black balls. See, an urn contains how many red balls? 5 red balls and 10 black balls. 8 of them are placed in another urn. Some 8 balls are taken. We don't know which 8 balls are there. They are placed in another urn. Okay. So in another urn there are 8 balls. What is the probability that the latter will contain 2 red and 6 black balls? What is the probability that I have chosen this one? In this there are 2 red balls and 6 black balls. Like this only I have chosen. What is the probability? So observe carefully. How many ways I can draw 8 balls from this whole set? In this whole set there are 15 balls. How many ways I can draw 8 balls? 15 C8, right? 8 balls, 15 balls, 15 balls are there. 8 balls, how many ways it can be drawn? 15 C8. That is the total number of ways. Now they are telling 2 red and 6 black balls have been drawn from here. What is the probability? Tell me. In this, 2 red balls are drawn from this one, 6 black balls are drawn from this one, obviously. So 5, 2. From 5, 2 are drawn, 5C2. From 10, 6 are drawn, 10C6. Divide by the total probability will give you the final answer. Okay, fine. Then we have the next one. A bag contains 8 white and 6 red balls. Find the probability of drawing 2 balls of the same color. Find out the probability of drawing 2 balls of the same color. How many balls are there? 8 plus 6, 14 balls are there. How many we are drawing? 2 balls we are drawing. So 14C2 will give us the total outcomes. Now 2 white balls can be drawn or 2 red balls can be drawn. See, or is coming here. Same color they have mentioned, they have not mentioned the color. So it can be either 2 white or 2 red. But both can't be like 2 white and 2 red, 4 balls. No, we are not drawing 4 balls, right? We are drawing 2 balls only. So either 2 red ball will be drawn or 2 white ball will be drawn. Right. So based on that, how many white balls can be drawn from 8 white balls? 8C2 ways. How many red balls can be drawn from 6 red balls? 6C2 ways. So total number of ways for drawing 2 same color balls is, since it is OR, we'll be using a plus operator here. So 8C2 plus 6C2, that is equal to 43, divided by the total number of possibilities, that is 91. Okay. Moving on, we have another question, which is here the base theorem is used. Okay, a box contains 2 white and 4 black balls. Okay, there is a box here. How many white are there? 2 white are there. And how many black are there? 4 black are there. Fine. Another box B contains 5 white and 7 black balls. Okay, how many white are there? 5 white are there and 7 black balls are there. Okay, a ball is transferred from the box A to box B. This is the box A, this is the box B. One ball is transferred from here. Okay, let's mention one ball. Then a ball is drawn from box B. Another ball is drawn from box B. Find the probability that it is white. Find the probability that it is white. What is the probability that it is the white ball which I am taking? Okay, so here some things you need to observe carefully. What they have asked us to calculate what is the probability of it being white. Okay, so you have to take 3 things here. Let even be the event that a white ball is transferred from box A to box B. That is the first thing which you have to consider. It is a white ball being transferred A1. The next option is either it could be transferred as black ball also. A to be the event that the black ball is transferred from box A to box B, and W be the event that the white ball is drawn from B. Three things happened. Either the white ball can be sent from this box, or the black ball can be sent and a white ball is drawn from here. So those three events I am denoting by A1, A2 and W. What is the probability of A1, probability of A2, probability of W when A1 was transferred, probability of W when A2 was transferred? That you have to mention here. Very simple. What is the probability of A1? A1 means white ball is transferred. How many ways you can pick white ball from here? How many balls are there total? 6 balls are there. Among 6, 2 balls are white. So 2 by 6 is the probability, which is nothing but 1 by 3. 1 by 3 is the probability that I can transfer a white ball. So P of A1 is 1 by 3. P of A2 is 2 by 3 in the same way. B is 4 by 6, which is nothing but 2 by 3. And what is the probability that a white ball will be drawn given that A1 was transferred? If A1 was transferred, then how many white ball will be there here? Instead of 5, it will be 6 white balls. Among 6 white balls, I am taking one ball. Sorry, 6 will be there, plus 7 is equal to 13. 13 balls will be there. Among that, 6 white balls are there. Fine. So the probability of taking the white ball is 6 by 13. Same goes for this one also. Probability of black ball is 5 by 13. So after writing this much data, what you are supposed to do is you have to calculate the probability of white ball, right? That the formula is given as P of W is equal to P of W A1 into P of A1 plus P of A2 into P of W by A2. That is the formula for conditional probability. So if you multiply these terms, all these terms are given up. If you substitute and multiply, you get the answer. Fine. Now this is also very simple. P of A is given to us, P of B and P of A intersection B is given. Find out this one. The formulas are given here. Just you have to read and substitute the answer. Okay, very simple ones. Just remember the formula, and substitution you already know. Now see here, this is another question. The probability of 3 students A, B, C solve a problem is 1 by 2, 1 by 3, 1 by 4 respectively. If the problem is simultaneously assigned to them, what is the probability that the problem will be solved? The problem will be solved if it is P of A union B union C. There is nothing but 1 minus P of A union B union C not. Right. If you add these both, you'll get 1. If you subtract this one from 1, you'll get as this one, right? So this can also be written as P of A, A bar intersection B bar intersection C bar. A, B and C are given. A bar intersection B bar, A bar, B bar and C bar is not given to us. So we can just calculate it. 1 minus 1 by 2 I'll be writing here. 1 minus 1 by 3 I'll be writing here. 1 minus 1 by 4 I'll be writing here, because not is given, right? I need to calculate the not value. Intersection means multiply, and I'll be subtracting 1 after multiplication of this one. That will give me the answer 3 by 4. Next one is, if all the words of the letter of the word engineer will be written in random, what is the probability that all the E's are found together? So first, whenever they ask this type of question, first thing you have to find is what is the total number of arrangements. Total number of arrangement is 8 factorial. Why 8 factorial? Engineer is a word which has 8 letters. So 8 factorial divided by 3 times E is appeared, 2 times N is appeared. So divide by that factorials. This you already know from the 11th standard. So these are total number of arrangements. If 3 E's are together, and consider 3 E's as one letter, because they have told us to consider 3 E's together, right? So if I consider 3 E's together as one letter, how many letters will be remaining? N, G, I, N, R. N, G, I, N, R. And along with that, these 3 letters. So how many letters are there? 1 2 3 4 5 6. 6 letters are there, and among that N is repeated twice. So what is the probability? 6 letters, 6 factorial, N is repeated twice, so 2 factorial. 360 ways can be found when triple E will be together. And among how many ways? Among 3360 ways, 360 ways are there. So this is the probability, 3 by 28. In a certain college, 4% of the boys and 1% of the girls are taller than 1.8 meters. See, any of these questions, simple step process, super simple step process, what you are supposed to do is read the question once, even if it doesn't make sense. See here, and get to know what they are asking. See here, in a certain college, 4% of the boys, okay, 1% of the girls are taller than 1.8 meter, okay. Furthermore, 60% of the students are girls, okay. If a student selected in random and found to be taller than 1.8 meter, what is the probability that the student is girl? Now what you are supposed to do, first observe what they have asked. What is the probability that a student is a girl? Okay, let B be the event that the student is boy. What is possible? Either he will be boy or girl, right? So B be the event that the student is boy, G be the event that the student is girl, T be the event that a student is taller than 1.8 meter. That's what you have to find out. Taller than 1.8 is given, boy is given, girl is given. Now just write the final answer what we need. What we need to find? We need to find this one, P of G by T. P probability that it is a girl given that it is taller than 1.8 meter. So write the formula here. In this formula, what all we need? P of T by G, P of G, P of T by B, P of B. Write those things. P of B is given 4% boys. P of G is given and as 0.6. 60% of the girls are 60% of the student are girls, right? And 1% of the sorry, this 4% is not this one. 60% are girls, so this is 0.6, and 40% are the boys, so P of B is 0.4. The taller ones, like what is the probability that a person is taller given that it is a boy? 4% boys are taller, so it is probability 0.04. And what is the probability that the person is taller given that it is a girl? 1% of the girls are taller, so therefore it is 0.01 only. If it is taller, what is the probability that it is taller given it is a girl is 0.01. Okay, after we have got that, just substitute the answer, we'll get the answer. Okay, so like that only the next of the questions are also there. If you observe carefully, you'll easily get to know one I will solve. And see here, the chances that a doctor will diagnose a disease correctly is 60%. The chance that a patient will die after the correct diagnosis is 40%. Chance of the death after the wrong diagnosis is 70%. If a patient dies, what is the probability that the disease was correctly diagnosed? Two possibilities are there: patient will die or not die. Disease is correctly diagnosed or not correctly diagnosed. Four possibilities are there. The question revolves around this only. What they are asking: if a patient dies, so circle this one. What is the probability that the disease was correctly diagnosed? Correctly diagnosed, they are asking this one. What is the probability that a disease is correctly diagnosed? Okay, this one here divided by given that a patient dies. P of C by D we know. We want to know. If you know the formula, you can easily get to know P of C by D we need, right? D by C into P of C divided by the two possibilities of this one and this one. That one you have to write. Okay, based on the formula, you can easily write it. The same thing they are also doing. A be the event that the doctor diagnosed disease correctly, B diagnosed the disease wrongly, and D given that a patient will die. They have asked about patient dies, so we need not have that probability where the patient doesn't die. Okay, observe carefully. What they have asked, that only we need. So we will mention that only. So what you are supposed to find out: D by A. What is D by? Sorry, you have to find out A by D. What is A by D? A be the even doctor will diagnose the disease correctly. What is that probability when a doctor will diagnose the disease correctly, given that the patient dies? Okay. So expansion of the formula you already know. You can write it, and P of D by A, P of D by A, and D by B all are given here as same as the previous question. You can substitute and find the answer. Okay, so that's all. Practice mode. These type of questions are mostly repeated, and make sure you hit the like button, subscribe to my channel. Your support helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.